In this video, I will show you how to solve similar triangles such as these for values of x. So the key thing is to match up the corresponding sides. And you really have to use the similarity statement to do that. Don't assume which ones match, which ones correspond. For example, side AC is this, AC. Now here's A, here's C. That's the beginning and the end. That corresponds with D and G. So that means, sorry, that's a C. That corresponds with D and C. So this is side DC. So these are corresponding sides. Similarly, okay, if I want to talk about side AB, AB is the first two, that corresponds with DE. And DE is over here, so these are corresponding sides. The next thing I always like to do is label one of these as new and one triangle as old. Now that's just so I can use the setup new over old equals new over old. It helps me organize my work and make sure that everything is in the right place when I set up my proportion. So let's do the yellows first. New over old will become x minus 5 over x plus 4. Now look at the blues. New over old will be 4 over 10. So now it's time to cross multiply. So we can multiply this diagonal, and that'll be one side of the equation. Before I do that, let me just remind you, when we multiply this diagonal, I'm doing 10 times x minus 5. I'm doing the distributive property. I'm doing 10 times x, and I'm doing 10 times 5. So you know I'm going to end up with 10x minus 50. But normally I will not write down this step. I can just see here that this 10 is going to be doing the distributive property. So I'll just do it and put the result on the very next line. So just understand that I'm doing the distributive property, and that's why I'm getting 10x minus 50 right now. Then I do the up diagonal for the other side of the equation, and again I'm doing the distributive property. I'm taking this 4 and I'm multiplying by the x, and I'm multiplying by the 4. So that's going to give me 4x plus 16. All right, I see I have x's on both sides of the equation, so let's subtract 4x from both sides. That's going to give me 6x minus 50 is equal to 16. Adding 50 to both sides will give me 6x is equal to 66. And finally, we will divide both sides by 6 and discover that x is equal to 11. All right, so that is how you solve a similar triangle. Let's do a few more examples. Again, the most crucial part is matching up the corresponding sides. So I see this x right here, that is TR. So here's T, here's R. That will correspond with L and J, LJ. And here's LJ right here, so that means these are corresponding sides. Okay, I see you have the 32 is the TS, and here's TS, that corresponds with KL. Here's KL. So these are corresponding sides. All right, I'm going to call this triangle new, and I'm going to call this one old. It doesn't really matter which one you pick as new and which one is old. If one triangle has an X and the other one doesn't, I'll usually pick the X triangle to be called new, but it really doesn't matter. And now I'm going to set up my proportion in the format new over old equals new over old. So let's start with the yellows. New over old is X over 48. Now the blues, new over old is 32 over 60. So time to cross multiply. All right, we do the down diagonal, and that will give us 60x on that side of the equation. Then we will do the up diagonal, multiply. So let's find out what 48 times 32 is. 1,536. And our last step will be to divide both sides by 60. So we get 25.6. I always get a little nervous when I get a decimal because very often the answers come out to whole numbers, but not always. So if we didn't make a careless mistake, then there you go. When the triangles are overlapping like this, my very strong recommendation to you is going to be draw the triangles separately. So, for example, I'm tracing the smaller triangle right now. All right, so here's the smaller triangle, and I'm just going to bring that off to the side. And now I'm going to trace the larger triangle. All right, let's bring that off to the side. Right, so again, whenever the triangles are overlapping, I really recommend that you separate them. So the smaller triangle was triangle PTS. Okay, and the larger triangle was triangle PQR. PQR. Okay, let's label them. So on the small triangle, we had side SP, which was 24. So I'm just going to get the 24 on there. And then side ST was x plus 4. So this is x plus 4. On the larger triangle, I see that QR is 2x minus 1. Now, what about QP? QP is made up of 24 and 12. You have to add those up. So that's going to be 36. So QP is going to be 36. Now, just like before, we have to be careful about which sides are corresponding. Don't assume that the 24 corresponds with the 36 and the x plus 4 corresponds with the 2x minus 1. Maybe, maybe not. We do not know that right now. We have to use the similarity statement above. Okay, so for example, I see my x plus 4, that is ST. So here's ST right here. That corresponds with QR. Okay, so in this case, those do match up kind of the way they look. So you can bet that these two are going to be corresponding, but let's let's follow through and check it out. Let's not assume things. That's how we mess up, people. So here is PS, and PS is right here in the front. That's going to correspond with PQ, which is right here. Always check, though. Doesn't always work out that way. So I'm going to call this one new, and I'm going to call this one old. So now I'm going to set up my equation in the form new over old equals new over old. Starting with the yellows, new over old would be x plus 4 over 2x minus 1. Now the blues, new over old will be 24 over 36. So, time to multiply. We're going to cross multiply. Remember that I am doing the distributive property right now. So I'm taking this 36 and I'm multiplying it by the x and the 4. So 36 times x is 36x. 36 times 4 is 144. All right, now let's do the other diagonal. And again, keep in mind we are doing the distributive property. We're multiplying 24 times 2x, and we're multiplying times negative 1. 24 times 2x is going to be 48x, and 24 times negative 1 is going to be negative 24. So we need to get these x's together, so let's subtract 36x from both sides. So that's going to leave me with 144 is equal to 12x minus 24. All right, we add 24 to both sides. So that's going to give us 12x is equal to 168. All right, then it's time to divide both sides by 12. And that is 14. And that's it. So x is equal to 14. All right, let's just do 2 more of these. All right, so again, the first step is to match up the corresponding sides. So I see we have 3x minus 2, that's KL. KL is the beginning and the end, so that's going to correspond with EB. EB is right here. Now 10, that's KH, first 2. That'll correspond with EF, that's right here. All right, now it is time for new and old. So as always, I'm going to set up my equation in the form new over old is equal to new over old. Starting with the yellows, the new over old will be 3x minus 2 over 4x plus 23. Okay, now the blues, new over old will be 10 over 25. Now we cross multiply. Let's take our down diagonal. And we're again doing the distributive property here. All right, we're taking this 25 and multiplying it by 3x and the negative 2. So that is going to give us 75x minus 50. All right, now let's do the up diagonal. And again, we are doing the distributive property. This time, we're multiplying the 10 times the 4x and the 23. So that will give us 40x plus 230. All right, let's get these x's together by subtracting 40x from both sides. So that's going to leave me with 35x minus 50 is equal to 230. Okay, now I'm going to add 50 to both, I'm going to add 50 to both sides. So that'll give me 35x is equal to 280. Last step is to divide both sides by 35. Eight. So x is equal to 8. All right, here comes the last problem. Watch out because this one does have an extra step to it. Yes, we're going to solve for x, but then we need to plug it in to find RT. So watch out for that extra step that we sometimes need to do. But the first step hasn't changed. We're still going to match up these corresponding sides. So 3x minus 1, that's WR. So here's W and R. That's going to correspond to TR. And here's TR. Okay, 8, that's YR. So that's going to correspond with RS, and here's RS. So we have matched them up now. I'm going to call this one new, and I'll call this one old. It really doesn't matter which one you pick as new and which one is old, as long as you stick to the format new over old equals new over old. So if I do the yellows, new over old will be 3x minus 1 over 5x plus 4. Now the blues, new over old, is 8 over 16. After that, it is time to cross multiply. All right, looking at the down diagonal, never forget that we are doing the distributive property. All right, we're taking the 16 and we're multiplying it by 3x and negative 1. So that's going to give us 48x minus 16. Now we look at the up diagonal. And again, we remember that we are doing the distributive property. We're going to take that 8 and we're going to multiply it by 5x, and we're going to multiply it by the 4. So that's going to give us 40x plus 32. Okay, let's get these x's together by subtracting 40x from both sides. That'll leave us with 8x minus 16 is equal to 32. Adding 16 to both sides gives us 8x is equal to 48. Okay, then we will divide both sides by 8, and we will end up with x is equal to 6. However, this is not the final answer. This is just phase 1. Now we're supposed to plug that in and find RT. Okay, so RT is right here. All right, RT is 5x plus 4. Okay, so RT is equal to 5x plus 4, but now we know that x is 6. That means that RT is going to be 5 times 6 plus 4. That's 30 plus 4, which of course is 34. And that is the final answer.